Good evening, ladies and gentlemen. My name is Struberg. I'm Apache Software Foundation member, and I contribute to about 20 or 30 open source projects, and mostly because I use them in real production. And I'm also one of the original authors of the CDI specification and config.jsr spec lead, and involved in the microprofile configuration stuff and other microprofile specifications. So I'm around since quite a few years. And my day job is helping customers to getting their stuff done. And with getting their stuff done, I mean really delivering products to production. And for me, the definition of done is if a product runs in production for 3 months, and if the users are at least decently happy. So I'm not just an ivory tower architect which talks about things, or a consultant which goes to the customers, talks about fancy new stuff and then is off the scene. I really do this thing in production. And in the last 5 years, I've seen many microservice projects, or projects who try to use microservice approaches. Why? Can only guess, but I assume because every second talk in the last 5 years was raving about how cool and good microservices are. And if you do monoliths or any other kind of application style, then you do it wrong and you should throw it away and replace it with microservices. And the question is this valid? Is this a valid argument? Okay, slide about me. You can reach me on Twitter, Struberg, at struberg@apache.org is my email address, so just drop me a mail if you want something. So the question is, there is an old saying from Paul Václavík, the philosopher, if you have just one hammer, every problem seems to or appears to be a nail. And I bet you have heard this proverb. In the German language, there is probably something even better. I translate this. This is, for every screw, there is a hammer which fits. And if you're a little bit a Tim Taylor and into homeworking, you immediately will recognize that if you have a screw and a wooden board and a hammer, it just doesn't work really well. And the question is microservice now the solution for everything, or is it just the screw and the hammer? Let's find out. So, in my opinion, how should it be? Use the right tool for the right job. This is my perfect strategy. We cannot always achieve this, but this is how it should be. In practice, you simply have to know that every design decision you take has some benefits and some downsides. And for some problems, it's a good fit, and for other problems, it's a complete mess. So let's go back in the hype cycle a little bit, because microservice is not the only hype, or is it a hype at all? Let's go back. What was the hype before microservices? What was the hype topic in all those conferences? In my experience, it's cloud. And would you use cloud for every problem, for every customer, for every application? And while cloud is really cool, for example, for Netflix, which is always the go-to example which people bring, cloud is so cool, because if it runs for Netflix, it also works for you, because Netflix is so big. But let's look at Netflix business. If you are Netflix, then you have about 1,000 times the traffic on a Christmas Eve than you have on a random Tuesday morning under the year. So for Netflix, it's essential then that you can scale up the servers and add servers dynamically if they need them. And if the Christmas Eve is over, then they shut them down again. And they don't need 10,000 boxes, spare boxes in their cellars or in their data centers, because they just rent them from Amazon. And that's it. And it's so much more price efficient for them. The question is, if you're now, let's say, an insurance company with 2,000 employees, do you really need this? Because your employers enter the building at 7 o'clock in the morning on Monday, and they leave it on Friday at 5 o'clock in the afternoon. And you have the same traffic Monday to Friday, 52 weeks a year. That's it. A single box can easily handle the traffic. Why do you need scaling in this case? Probably have a second box for outage reasons, so you can balance the nodes and so on. But that's it. You don't need any scaling like Netflix. So the message is, for some use cases, cloud is cool. For other use cases, it's complete overkill, and it's actually not that cheap. It totally depends what you need. think just what you need and what cloud benefits are, and whether it is probably better to keep it in-house. For example, for data safety reasons. If you're a governmental company, you are not even legally allowed to host stuff in the cloud which is not European-based. So what is the next hype? Big data. Let's go to big data. Big data is cool, and in about 2014 or 13, this big data hype came up, and everybody wanted to use big data. And customers came and say, oh, I have 200,000 customers, or companies of mine came, I have 200,000 customers, this is so much, I need a big data solution. But actually 200,000 customers, it's a lot customers, but it's nowhere near big data. So everything under 10 billion rows is not big data for me personally. So you could probably, it would be much smarter to just have a database replication backup and restore it to some temporary box and to use standard SQL for it to analyze your data. You might be much faster. You could create temporary indexes and temporary tables and whatever. SQL is easy to learn and much more efficient than setting up a big data installation. So does it mean that big data is crap and you cannot use it, or it doesn't make any sense? And I'll give you an example for another project which we did, or colleagues of mine did. This is for a bunch of hospitals who work together. And in a hospital you have typically, you do computer tomography scans, magnet resonance scans and stuff like that. And each file has about between 50 megabytes and a gigabyte. So over a year you get about a few hundred terabytes. So this is, and if you want to store a few years, then you are near 3, 4, 5 petabytes of storage you need. This is way too much to fit on one box. So you couldn't afford this. What we did is we bought 100 standard servers with 16 3.5-inch 8 terabyte drives, which gives you per box, per server, 140 terabytes, 100 times, is 14 petabyte raw storage. Of course, via the replication, you lose something, 1/3, so you have about 5 petabytes netto storage, which you can use. And you have 100 boxes, which with each course, 16 threads each. So you could use the MapReduce from Hadoop, for example, to do cancer calculation, oncologic research, which is used by the university, by the way. So you have big data solutions where you need to make use of the huge HDFS distributed file system, which is basically a software RAID distributed over the whole network. And you can make use of the multiple CPU cores you have in the 100 boxes, because you can spread out with MapReduce your problems, your analytics, and with the reduce you get back the results. And this is a good example for using big data in my eyes. What was the next type? NoSQL. Did NoSQL replace traditional databases? I didn't see this happen. Does this mean that NoSQL is nonsense? Of course not. So if you have, for example, a mobile provider and you have to store 10 billion of connection infos per week, then of course any traditional relational database is completely wasted. They will not manage to keep this information. So you could probably go with Apache Cassandra and store this. And it's a perfect solution for this. But for most of the business projects, a standard classical relational database is still so much better. And in all those cases, it turned out that we have kind of a 20% where the hype team, this topic, is really good fit. And the other cases, it's kind of overkill. So it's good to know those tools. And every time we have such a hype, we add new tools to our ballpark. But it doesn't mean that we have to apply them to every problem. At least that's my takeaway, my personal takeaway. So my point is to understand what the new tool is providing, what the new architecture approach is providing as benefits, what the downsides are of this approach, and then apply it to your problem. So you have to understand your problem, and you have to understand your tools. And only then you can judge whether your tool, in this case MicroServices, is a good fit or not. And this is really crucial. And many of my customers skip this process. They just said, oh, microservices is the cool new way. Let's do it. Let's try it out. And this is fine to play with it. But it's a little bit, too ambitious to kind of jump the horse and put all your money, all your bets on this. So let's go into microservices. Who has microservices in production? 1, 2, about 5. Who has never heard about microservices? Okay, only just a few ones. And who is planning to do microservices in the future? Okay, quite a bunch. Okay, I hope I give you some some little bit of insight or a few points. This is actually an extract of a talk I gave at the university and started 3 years ago. And back then the people said, oh, you're crazy. Microservices is the new cool stuff, and we do it. It was 2 hours, so it's only an extract. And there are many, many more things which you have to think about if you really go microservices. But I hope this gets you in the right mindset to start thinking for yourself. So what is microservice? Or otherwise, let's say it that way. Why do we start thinking, or why did we initially start thinking about microservices? So if microservices are the answer, what was the initial problem we wanted to solve with it? And the answer to this is we had some bunch of monoliths mostly, so biggish old applications, and we are not happy with those. Because many old monoliths are really hard to manage, are really hard to maintain, is a piece of crap sometimes of source code which evolved over 10-15 years, and now you have to maintain this stuff. And I perfectly see why people are unhappy with this. If you have a system which evolves over time, people tend to add pieces as they need it, and often without understanding the structure of the systems. They adding features left and right, and adding kind of contact information to the contracts and whatever. So what the result of this is that you get interdependencies between different source blocks which create cycles and stuff like that. And it's really, really hard to maintain those sources. There is most of the time it misses complete modularity. So it's just one big source block, and you have no clue where you should add one feature. So there is no clear separation of concern, Conway's law, and what you probably heard about it. So keep your the domain logic as parts, as modular parts. In most old monoliths, you don't have this. Well, no easy to scale. I have to explain this a little bit. It's not about the source code because, it's not about runtime scaling, because scaling a monolith is just starting up a second node most times and load balancing the traffic to the second node, and you're done. You have twice the load. If your problem isn't in the database, which is the bottleneck then. But this is meant to be... Sorry? Okay, this is meant to scale from a business aspect. So if you want to add a new functionality, let's say we have our insurance company and this is buying another specialized entity, and this business should be integrated into the application. Since there is no modularity in their old application, they just add the features over there, and a little bit in the customer, and a little bit in the contract information. So they don't have a clean modularity, and so it's really hard to enhance or add additional business features without having to retest all the application. So every time you touch a big monolith, you have to retest all the stuff again, because you cannot be sure that you didn't break existing things. And this is the same, in the same target is the hard to roll out. Deployment-wise, a rollout of a monolith is the easiest you can do. Just update the database, drop the old binary, start a new binary, and you're done. But for me personally, a rollout doesn't only mean delivering the binary. It means I have an old functionality. I add new features. I must make sure that the old functionality and the new features run in production perfectly well. This is a rollout for me. It's not just dropping the WAR file and be done. This is only a single part, and this is the easy part. ensuring that the old functionality and the new functionality is running again without having some side effects. This is a hard part in monoliths because of the side effects and the missing modularity. So the answer was microservices to all those problems. I bet you how many people did experience such problems in production? Yeah, a bunch. And I feel your pain. I'm definitely with you. And that was the reason why microservices got born. So what is a microservice? Let's Google that. And if you Google microservice, then you will come up, this was back then the first hit on Google from SmartBear, which I think SoapUI is from them or something like that. So they are well known in the business, and I found this a pretty good definition, but it's just one definition. It's like with SOA, there was no real definition for microservices, and there is still no. So everybody understands a little bit different things about microservices. But I think this is a pretty good summary. Essentially, microservice architecture, so it's about an architectural style, is a method of developing software applications, so all those microservices together will be one big application, as a suite of independently deployable small modular services. So we cut up our whole big bunch of business into small modular services and let them run independently. That's okay so far. In which each service runs as a unique process. Okay, this is a little bit more specific. So you have either a Java process or JVM or Docker or whatever, and communicate through a well-defined lightweight mechanism. So what is this lightweight mechanism? Might be, many people will say REST, but it's actually wrong. In most of the cases, it's not REST, but they're actually using JSON plus HTTP. So they, most of the time, still do a imperative style and not a resource-oriented style. So what they're doing is remote procedure calls over HTTP plus JSON. And this has nothing to do with REST architecture, by the way. But this would be a separate talk. But it could also be, well, messaging, eventing, a binary protocol like JSON, for example. It's not really defined to serve a business goal. So this is really cool. All my microservices should, again, serve one business goal. Okay, reads good. Let's look at the different parts of this sentence. The first is small independent services. So how big is a small system? How big is a microservice? Who is writing microservices already? And how big are your microservices? A few classes. Okay. How do you make it up? Is it classes? Is it functionality? Is it binary size? How is a small? How do you define a small service? Okay, single purpose, single feature, single domain. That's a good point, because many of those say, oh, it's about binary size. And if you look at classical microservices, then they are actually cruel in binary size. So what are you using? Spring Boot with web app. Okay, and how big is your application, Spring Boot application? Okay, in my Spring Boot is really cool, and if people go to start Spring.io and just generate this hub, they come down with a 80 megabyte of microservice. So a microservice is usually, if you go to standard Spring, way 80 megabytes. Well, I'm not quite sure if I call this micro, but this isn't the end. The end is people then manages and add new features, and over time Spring changes the versions, and then they have to update, for example, ACG, the security layer, and suddenly the versions don't fit together. And if you go to Stack Overflow, then there is a standard solution for this. Oh, use the parent POM or the BOM of Spring and import this to your Maven project. But this sucks in so many more dependencies that suddenly then you have 120 megabytes of dependencies if you don't take care. So that doesn't mean that with Spring Boot you have to be that fat. You can also, if you hand tweak it, you can get down to about 35, 40 megabytes. But most of the microservices I've seen, they are about 80 to 120 megabytes, which I don't call micro actually. So how big is a Java Enterprise server in contrast? How big is WebLogic, WebSphere? What do you guess? A gigabyte, a 30 gigabyte, yeah. The oldish servers are really that fat. That's true. They're really huge. But a modern server is kind of Glassfish has about 120 megabytes. Red Hat Wildfire is about the same. Apache Tommy has about 35 megabytes. And Apache Microwave, which is a smallish microprofile-based server, which is the Java Enterprise core, basically, is 9 megabytes. So, and if you add your application to it, then you're about, well, 9, 10 megabytes, something like that. I can showcase this quickly if I manage to get it right. So this is kind of, and this is how simple an application in Java Enterprise looks like these days. So people rave about, oh, it's so easy to do Spring applications, but the people obviously didn't look at Java Enterprise for ages. And this is kind of the only class you need to create a microservice in Java Enterprise or in MicroProfile. Let's move this up there as well. This is really, let's look just at the source folder. It's really one test, and this is the whole application, one. And it starts up in, I've compiled it before. Can you see this? So it boots up in 384 milliseconds. So it's pretty fast. This doesn't take minutes, it takes a few hundred milliseconds. And you have it there, and I can invoke this if I have a browser here. Oops. Yeah. Okay. So it's really that plain simple to do Java Enterprise or microprofile applications these days. And yeah, a nice thing is, I want to show is, let's quit this down. There is also a way to bundle this. This basically includes Tomcat, the latest Tomcat 9.0.12, CDI container, JAX-RS, JAX-WS, JSON-P, JSON-B, and logging perfectly set up. And and that's it. And this also has a few other stuff like Log4j setup. If you remove Log4j from here, because Log4j became a bit too big in my opinion, and if you switch down to Java util logging, you come under 8 megabytes for a whole Tomcat with a Java Enterprise core. So this is really neat. And this is, in my opinion, how a microservice should look like. So, okay, what's the next part of this microservice definition we had before? Independent services. Oh, that's really neat. So microservices are modularized because you have a network boundary. You cannot get ugly and just jump over to the other class because it's on the class path. You have to go over the network boundary. But does that mean that they're really independent? Yeah, that's a question. Because if your business relies on each other, and if your business logic has cycles, then there is no way to get rid of the cycles in the technical layer. If there is a business logic who says, my customer needs to know the contracts and the contracts need to know the customers, then you need to do this link. And regardless whether you do it in the JVM or you go over the network in a microservice, you have this link back. And the more complicated your business logic is, the more such interdependencies you will get. And Netflix is pretty happy because the main business of Netflix is dog simple. Netflix is not a good example for microservices at all. Okay, it's a perfect example for microservices, but it's a bad way to say it works for Netflix, it also must work for us, because the business of Netflix is just delivering binaries, streaming, and that's it. Many business applications have so much more business logic, so much more complicated rules than Netflix has. Netflix does an amazing job in delivering tons of content, and the technical aspect is huge. I mean, serving terabytes per second. This is huge. But from the business aspect, from the business logic, it's pretty simple, actually. So you can't compare those two. And if your business is interrelated, you also need to kind of implement this in your technological stack. That's it. Deal with it. So you will have those dependencies on each other. The only thing you could do is, if you upgrade one logic, for example, your customer part, the European Data Protection Regulation came out last year. So many microservice customers of mine had to remove the history of users, had to remove information from the user, because they are not allowed to extract this, serve this anymore via the microservices. So had to remove functionality. Do you add a new customer service? Okay, and this new customer service doesn't give you information. So you have to also upgrade all the callers, because you have to handle this, that they now don't get the data they expected before. So what could you do? Versioning. You could introduce different endpoints. You could introduce just returning empty customer information, but then the business logic on the other side will probably bork up. So it's hard to do. But you have, if you have independently deployable binaries, microservices, then you need to find a way to make them exchange and upgrade parts of it, without breaking the other parts. And this really, when you have complicated business rules, this is really some work to do. The other thing is, it's really easy to add new features, but how do you get rid of features? How do you get rid of unused code? So microservices is pretty young, but I already see projects which has a lot of dead code in there. How do you detect if some functionality is not used anymore? This is not as easy as it looks at the first place, because if I have a monolith, what do? I open my NetBeans or IntelliJ or whatever, find usage. And if there is no one calling me, I can just get rid of this whole method. And then I do an analysis, and I find even more methods or classes which are not used, because this was actually the only user, and you have a whole tree sitting there which is now unused. And so you can iterate and clean up your code base. Now do this with a microservice. Do you have any ideas how you could detect if a feature is unused in a microservice deployment with 120 microservices, a Kubernetes cluster, for example? Any ideas? Tests, yeah, but if tests test some feature and you don't use it in production anymore, then, well, you have coverage. But if the coverage is only in the test, then... Yeah, metrics, data scanning, network scanning, basically. So if you have Istio mesh, so who knows Istio? Yeah, okay, it's kind of a proxy layer on the application side, which is not part of your application, but actually in the container side. And you could do other tricks to measure content and invocations. And then you can say, okay, this endpoint didn't get called for a few months. So it's probably unused. So traffic analyzing, hit analyzing. This is what you can do. But it's just a rule of thumbs, because we had the problem that customers did this and removed it. And then this was... yeah, bad luck. It was used, it was called in the end of year calculation. So this was a job which is only running in the first week of January, and well, the endpoints are not there anymore. So you blow up. This happens. Or another funny case we had is a fallback service if the primary service is not available. Think you have a recommendation system which is external. And if this external recommendation system doesn't react anymore, you kind of fall back to your default hard-coded few items, just to don't have the space on your basket empty. So this fallback didn't see any traffic for a long time, because the vendor of the recommendation system is reliable, but eventually he was down. And then we figured that our fallback system is also not here anymore, because Yes, we had no traffic for a long time, so we removed it. Those are things which happen. And you have to, the problem is in code, you can't just make find usage. Now with microservices, you have to go through all the 120 microservices, which probably could call you and verify that it's not really used anymore. Or you just live with it and say, okay, things happen, bad luck, and I'll add it again for the next time and document it better. Okay, independent data. So to come back on this again, it's easy to add functionality to microservices. It's pretty hard to get rid of functionality from microservices. So the code base tends to grow and grow and grow. And it doesn't get, like with code, it doesn't throw itself away. But it's much more harder to detect what you could probably throw away. So independent data, this is also such a thing. In theory, it's good that every domain, every microservice has its own database, or its own schema at least. Because then you don't get this kind of, if you look at some old applications, you always have database spaghetti. You pick one table and it has foreign relations to almost everywhere, and you have the whole database in your hand. And this effectively prevents such a situation. On the other hand, if you have independent data, like for example, a customer and the bills of this customer, and you can't have a database relation between those two and no constraint, then you could kind of delete the customer without deleting the bills. Or the database doesn't even prevent you from deleting the customer because, well, if you have open bills, well, you shouldn't probably delete the customer. But if the customer and the receipts and the bills are sitting in different databases, the database can't protect the situation. You have to do this via hand. So you have to take care about this additionally in the code. So it's more code you have to add because of features that database cannot provide you anymore. Those are things you usually don't think about this until it happens. And then you have broken data. This is also something which makes NetBeans completely different from a casual business project. Netflix doesn't care about a single purchase. Why? It's a few cents. You have a voucher anyway, so you have a recurring, you pay per month, so it doesn't matter how much you download. So on the other hand, if you're for example, let's make something up, a leasing company, and one single row in the database might represent a value of a car. Or if this leasing contract is about a house, like a industry building, then it might represent a value of 20 million euros. So having consistent data in your database is the number one key thing you need to take care in 99% of all business applications. For Netflix, it totally doesn't matter. So you really can't compare those two. So the argument it works for Netflix, it has to work for us, is just bollocks. Sorry to be that clear. I mean, of course, depends on your style of application, what you're using, or the problem, again. Independent, I skipped this because of time reasons, but most of the times if you're in Java, it's all perfectly fine. If you use different, one key benefit of using microservices, you could program every microservice in a different language, and that's perfectly fine. If you, for example, use Kafka as messaging, eventing system in between, and you want to write Erlang or Haskell, I'm not quite sure if there are Kafka clients for Erlang and Haskell. So in practice, it might be a little bit restricted when it comes to messaging. Okay, another really big pain point if you go to microservices is transactionality and data consistency. What I said before. Sorry, I have to sneeze a little bit. So again, our leasing company, a row might represent a value of 20 million. So you better make sure your database is consistent. And distributed transactions, or actually transactionality in the database, is since 1973 Ted introduced SQL and transactions. And since then, our programming model is different. We rely on transactions usually. So who is not using transactions in their applications? None. we just we begin something, we update some tables, and we say commit or rollback, and then we treat it as atomic. We are used to that. It's almost our DNA nowadays. We are not aware, or not aware anymore, that we only have this since 1973. Before that, each table, I happen to maintain really ancient big bank applications, and every database table, which flat files back then, ISM files, had two fields, a status and a substatus. If you insert the customer and it has 3 addresses, then you say insert customer, insert address 1, insert address 2, insert address 3, commit. Or rollback if something goes wrong. Now, if you imagine not having transactions anymore, what happens? If you go over microservices and the address service and the customer service are different microservices, what happens? Create a customer, calls to system 1. Create address 1, create address 2, boom, network down. What happens? Of course, you have a customer with 1 address, but actually has 3 addresses. So you have inconsistent data. And this is kind of, there is no way to do it, because if you would use XA over microservices, it would completely trash your throughput. Because, do we have the time? As I said, this talk is actually 2 hours long, and there are many, many more points. The thing is, two-phase commit works. You have multiple resources, and if they are XA aware, you say prepare, 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 and then you say in the second phase, you say go, 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 go. And between the prepare and the go, the database must make sure that nothing happens. How do they do that? Mostly by locking. In some special cases, they can avoid locking, but between the prepare and the go, you have locking. Now, figure if the prepare and the go is over a web service or some external layer and it takes 100 milliseconds. Then you can do 10 commits per second. So your throughput is completely gone. So in practice, systems refuse, or XA managers refuse two-phase commit if a transaction takes longer than 5 milliseconds about. So you can't do XA over microservices really well. This is a mathematical problem. So you have to go back to the pre-73 solution. Like every database row has 2 fields, status, substatus. I created the customer. I started creating the addresses. Substatus 1, I've created 1 address. Substatus 2, I've created 2 addresses, and so on. And if you fail, then you have to pick it up asynchronously via a batch. That's the reason why old applications have so many dozen batches, hundreds of batches, because they pick up the stale state and propagate it if something fails. What is the other solution? Eventing, or a state engine, like a process engine, for example, where you have this state not in fields in your own database, but in a process engine. But then you can guarantee consistent data. Or you don't care about consistency like NetBeans. But for business application, I highly recommend that your data consistency is king. So what do you do in case of a failure? Because what we are also used to is that we start a transaction, we do something in the database or in resources, and then we say commit. And if something happens, something blows up with a null pointer or inconsistency in the database, you get an exception, it bubbles up to the stack. And somewhere in the stack, you have an interceptor. Is this the same in Spring or in Java Enterprise? And this interceptor says, oh, there is some exception I didn't expect, so I'm gonna roll down all this stuff. So if people don't care or don't be really, really careful, and if you have 100 programmers, then 10 of them are really exceptionally good. So let's say 30 are really good, and for a few others, you better say they shouldn't touch the code, but they are touching the code. So doing error handling right is really, really crucial. And if you have microservices, you must get it right, because the database, the transaction handling, isn't preventing data consistency anymore because you don't have it. So you have to find ways, and now we laugh about SOA, service-oriented architecture, but service-oriented architecture did bring us a few good, let's say, patterns, and one is compensation. But you have to code this compensation. What is a compensation? If you detect a failure, you kind of cry to microservice, oh, no, sorry, it didn't happen, gonna delete me the address and the user. But you have to code all those things yourself. Compensation logic is to be done in the source code. There is no rollback, no guaranteed atomicity. So error handling, getting error handling right is really, really a lot of effort. And if who has done C programming, and if you remember the old days where we didn't have exceptions, you had one call to a function and such a block of error handling. And then you have, again, one call to a function, such a block of error handling. Welcome back to those days. And we still need a way to find a solution for this. Some approaches are there in microprofile with fault tolerance, but it also depends on, it kind of is an automated way to help with compensations. But it's not perfect. Persistent messaging with Kafka and other bus is also a solution for this state handling, but you really need to be careful. Each step which modifies state in another system needs to be handled as a single message. And you kind of are architectural-wise, you are back to a enterprise service bus pattern. Just that you replace the enterprise service bus, like I don't say any names, with Kafka now, or with another event broker. A centralized event broker. So Netflix does all that? Of course not. Or Apple. It's the same, basically. If you purchase some app from Apple and you don't get it, it doesn't work on your phone. You just say it didn't work and you immediately get back your money. There's not even a person backing this process. Why? Because giving you the $2.50 back is just so much easier than having a person which calls you on the phone for 3 minutes. So, and they don't care about it. So well, it's a different kind of business as most business applications. So, and 7 minutes left. There are another thing which I highly recommend to think through is Fallacies of distributed computing, which is about 1986, because all the problems we are talking now in microservices has actually nothing to do with Java, has nothing to do with Spring versus Java Enterprise, has nothing to do with Linux versus Windows or something else. It has to be with local central systems versus distributed computing. And the Fallacies of distributed computing was written by Al Deutsch. It was one of the first Sun employees, I think in 1986, if I have got this correctly. And there are some things like network is reliable. Well, yeah. Latency is 0. How much time does it cost to make 10 million calls to a method in Java? 10 million. We are talking about milliseconds here. And now to 10 million HTTP JSON calls. This is hours. So there is a huge difference what you do there. The other thing, well, we have 6 minutes. Should we go? Okay, give me 2 minutes and then I do questions. Yeah? The testing is also really, really problematic because how do you test microservice? If you have a monolith, you can do a nice integration testing stuff. In microservices, you really need a staging, and then you need to guarantee that the staging is exactly the same like in production. And only one team can test on the staging machine. Because if you the team A updates the customer system and the team B tests the billing system and they work fine in test, but actually the billing system doesn't get updated, and the customer system, the customer service gets propagated to production, and then you get aware that, well, you miss a new functionality of the billing system, which by accident was available in the staging. So those are the things which you only hit when you run those things in production. And before that, on paper, nobody thinks about those complications. So the orchestration of those 120 microservices is tons of work. And the question is it worth for your application? Do you really need a single part to be so independently? And if it's just about the modularity, why can't you just do the modularity with a Maven build? introduce a multi-module Maven build, which has separated API, backend, and front-end parts, for example, like we did. And then you can do the modularity during the build time and package all this stuff in a single WAR file, for example. And at runtime, you have the big ball of mud, but at least at the development time, you have modularity. And this solves 90% of the problems with monoliths. But it's also just a bunch of work. What's the takeaway? You can solve all the problems of a monolith by going microservice, or most of the problems with monoliths. And the other way is also correct. You can solve most of the problems with microservices by going back to a monolith. These are kind of two sides of the same coin. This is not exclusive or, and I won't say microservice is bad, monoliths are good, or the other way around. It totally depends on your business you have. And you have to just question those things and the fundamental problems. And there are always trade-offs involved. You just have to make sure that the trade-offs are more important or not for your problem. And this might be a different answer for every project you have. So, yeah. Ta-da. What can we take away from all this microservice hype? Like with SOA and so, we learned so many cool tricks with SOA and with big data and with NoSQL. What are the tricks we can take away from the microservice hype? If, let's say, in 5 years nobody will build microservices anymore. It's definitely things like circuit breakers. What is this? Even a monolith, you have to go to remote systems often. Like you have a server for printing, you have a server for document archive, you have SAP which you have to talk to. And if, for example, the document archive is down because it's on maintenance, and you have an application which is mostly like digitalization, it's data-driven or document-driven, then you quickly have 400 threads waiting on the document server. And your whole application server is down because all of them are waiting for the document server. And this is a perfect trick where you, even a monolith, can use circuit breakers, which kind of got popularized by the microservices. So what is a circuit breaker? Who knows what a circuit breaker is? Ta-da! Okay, it's basically an interceptor which counts how many outgoing connections you have to a single system. And if you say you hit more than 10 outgoing calls, you say, oops, the remote system is not busy. And the 11th parallel call will just immediately throw this exception remote system busy or what else, or to some other task to tell you there is no way to access this system. And if the remote system is back up again, it will kind of open the gates again, close the circuit, and let the content, the requests through. And then you have normal operation. And for example, in your application, you could react on this and say, oh, I got a remote system busy exception, so I can notify the user the document archive is temporarily not available, but he can still do some other stuff. The server is not hanging. And this is really cool with circuit breakers, and you should really look into it. Distributed log correlation, to pick something else. If you go out to different systems, it's basically add a HTTP header, propagate it over if... you can do this with a servlet filter. Like I've done this since 10 years, actually longer. And if you have a X log correlation ID, HTTP header, you take this, write it as map diagnostic context into your log4j or SLF4j, and then with every log line you have, you get the log correlation ID printed out. And so you can follow requests through systems. It's also a very nice trick which kind of got popular via microservices. But it's perfectly usable for other situations as well. And there are quite a few such tricks, and we have to kind of extract them and apply them to whatever the solution we have if they are a good fit. Not blindly, but only if they're a good fit. Okay, that's pretty much it. Any questions? I have 43 seconds for questions. I hope I didn't bore you, because it was kind of a high-level talk without too much technical details, but yeah.
Based on your experience, what was the perfect fit for microservices regarding business perspective application?
It's the combination of microservice and cloud is pretty straight, because most of the arguments are for both. So if you have high scaling, high dynamic scaling, then and the parts scale differently. So if you have high scaling differences, then it's good for cloud and microservice, and even more if the single parts scale differently. So because you can scale up your recommender system differently, like your customer system. And it only is worth it if you have a certain throughput. So public internet application with 100,000 requests plus per second. This is my now let's say 1,000 requests plus per second. So we have a monolith which easily serves 20,000 requests per minute on a standard server. Easily, without getting any sweat. So, yeah. And if your business project, it's only, you have to weight the criteria. If you need high consistency, then make rather bigger parts. That doesn't mean that you have to build a single monolith for the whole application. We never have this in my customers. You always have biggish applications which work with each other. Like example, you have the customer relation management system. You have the billing system. You have the, those kind of things. And they talk with each other. But I wouldn't call them microservices because they have their own UI. They are really up to a few thousand classes. But they are also definitely not a monolith, because the whole company has multi-applications and each team is responsible for one of the applications. But those teams are rather big. The domain logic is rather big. And inside the domain, we have really strict consistency rules and transactions and constraints in the database and so on. But they are still a distributed system. But the balls are really much bigger. Any more questions? By the way, this application deals with multiple billion of euros. So, okay, then thanks for having me. Hope you enjoyed the talk.